Hello, dear students. Welcome back to our chemistry curriculum. And let's continue our new section 4.1, which is how are elements organized or how are elements classified. Let me ask you a question first. What if you have a large number of books distributed in your room in different fields, and once your friends asked you to borrow one book talking about the atom, for example. So to search and find this book, you will take a lot of time because you didn't arrange or classify these books in a library, for example. This is the main concept or the main idea that led some scientists to classify or organize elements of the periodic table. The story started since 1869, when the scientist Dmitry Mendeleev started or thought to classify elements in a table according to their properties and their atomic mass. The purpose was to make the study of elements more easy. So we classified elements to make their study more easy and to find relations between these elements. The first attempt or the first trial made to classify elements was made by Dmitry Mendeleev in 1869. So we call Dmitry Mendeleev is the father of the periodic table. At his time, there were about 63 to 67 elements discovered, and he was studying the atomic masses of these elements. Then he started to write each element in a piece of cardboard. He wrote the symbol of element and wrote below this or below each element the physical properties he knows about the element. For example, he wrote the density, boiling point, melting point, conducting electricity or conducting heat, and so on. Why did he wrote these properties or these physical properties? To find relations between elements and each others and make this arrangement worth to be used. Mendeleev arranged the elements according to their atomic mass in an ascending order. And ascending means increasing from the smallest to the largest atomic mass. He found that the properties of elements are repeated periodically or repeated at regular or equal intervals. So Mendeleev was the first scientist to think about classifying elements, but at his time, not all the elements were discovered yet, so not all the atomic masses was known yet. So from the privilege or the advantages of Mendeleev's table, that he left gaps, as you see here in this figure, here, like this, and here. He left a lot of gaps in his table, predicting that these elements are not discovered and it would be discovered yet. So the atomic masses will be written here to complete his table. The second thing Mendeleev made was that these elements was not always fitting their order in the atomic masses on the table. So he began to reverse the arrangement of some elements to let each group or each vertical column contain elements of the same properties. For example, let's suppose that this group, for example, the second group here, contains all the elements have the same properties, but one of these elements doesn't match the properties, but another one here matches the properties. So he will reverse or replace these two elements together that may affect the arrangement of the atomic masses, but he meant to make the element properties suitable or fitting each group. He also added at the right side of the table a group called the noble gases. After Mendeleev's table and after his adventures and disadventures, another scientist called Henry Mosley, and he was in the time of discovering X-rays and discovering a lot of technologies that help in discovering more details about the atomic structure. So at his time, atomic number was known. As you know that Mendeleev didn't study atomic number, but he studied atomic mass. But at Henry Mosley's time, Rutherford was discovered already the number of protons inside the nucleus, and he found the nucleus. So we began to calculate the atomic number. From this time, Henry Mosley started to arrange the elements at the same theme or the same idea of Mendeleev's table, but he used the atomic number instead of the atomic mass. He arranged the elements in an ascending order too. It means from the smallest atomic number to the largest atomic numbers. The new thing here is that the gaps of Mendeleev's table has disappeared. Mosley's work led to both modern definition of atomic number, and he showed the atomic number, not atomic mass, that atomic number is the basis of organizing elements according to their properties. So this sentence means that the atomic number is the most effective in defining the elements' properties or in arranging or classifying elements. After that, or after Henry Mosley's work on the periodic table, a group of scientists began to work to arrange the modern periodic table as you see in this figure. This is the modern periodic table, which include about 18 vertical columns. And when I see vertical column, I'm pointing at them now. This is a vertical column. We have 18 vertical columns. We call these vertical columns, each one is called group or family, because it contains the same properties of elements in each group. And also the periodic table contains 7 horizontal periods. As you see here, horizontal columns or horizontal lines, horizontal rows, we call these rows periods. After Mosley's work, he also assigned at the right table or the right side of the periodic table, assigned the elements noble gases at group 18, and he added below the table 2 periods called the lanthanides and actinides, because these 2 groups was too large. So if we put them inside here at the middle of the table, it will make the table is too wide to be studied and will affect the shape or general shape of the table. So he added or put these 2 periods below the table, and they called it lanthanides and actinides. These groups, or sorry, these periods are period 6 and period 7. Finally, I will tell you something we have reached after classifying elements by the work of Mendeleev, Mosley, and the modern periodic table. They found that there's something called the periodic law. Periodic law states that when elements are arranged according to their atomic number, elements with similar properties appear at regular intervals. Again, when elements are arranged according to their atomic number, the elements with similar properties appears at regular intervals. Let me show you what is meant by regular intervals. I will start here at period 2, for example, at element Li, lithium, and I will move horizontally till I will finish this period. When I start another period, I will find sodium, which has the same properties of lithium, and so on. When I finish the period, I'll start again at the same point. So at certain intervals or at certain times, at repeated points, I can find elements with similar properties, and this is why we call it the periodic law. Finally, organization of periodic table was in columns, which are groups or families, according to the number, which contain the same number of electrons at the outermost energy levels. And we call these electrons valence electrons. Next time, inshallah, we will study together the valence electrons. Thanks for listening.